In this video, we're going to look at areas of different quadrilaterals. So a quadrilateral, first of all, is a four-sided shape, and there are lots of different quadrilaterals with lots of different area formulas. Okay, the first shape we're going to look at is a parallelogram, and the area of a parallelogram is base times perpendicular height. So I'm just going to show you roughly where this comes from. So if you imagine we had a rectangle. Use your imagination here, not a very nice rectangle. If you've got a rectangle and you chop this little bit off here and then you put it on to this side, so it disappears off that side, goes on to this one, then what you're left with is a parallelogram. So if it had been the original rectangle, which was just that shape, it would have been base times a height. And if our new shape is made by the same dimensions, base and the same height, then the area of the parallelogram is also base times height. So to find the area of the parallelogram, it's base times, and what they say is perpendicular height. So it's not that slant height, it's this height up this way. So its area of the parallelogram is base times the perpendicular height. Okay, in this particular example we'll just say area is equal to B times H, and your B is 14, your H is 5, and if you do that, you're just going to get 70, and remember your units for area, 70 millimeters it is in this case, so millimeters squared. Okay, the next one we're going to look at is a trapezium. Recognizing a trapezium is tricky for some people. Trapezium has one pair of parallel sides, so these are ones that people find not too bad. Whenever it's what's called a horizontal trapezium, but if it's a vertical trapezium, so an example of one you may see way later on in maths would be something like this. So this is a vertical trapezium. So here the parallel sides are the vertical ones, and the perpendicular height is actually horizontally in this case. So you have to look for the parallel sides. Once you find the parallel sides, label them A and B, and then the other dimension across from those, perpendicularly across from those, is going to be your H. So the area of a trapezium is, a half upon A plus B times H. Can you add in to your notes? And this is what you'll remember for a long time. A half times the sum of the parallel sides times the perpendicular distance excuse my handwriting, perpendicular distance between them. Okay, so much easier for you to learn that off, or that will stay with you a lot longer. So it's a half times the sum of the parallel sides. So have a look at what we've done here. A and B were the parallel sides. We've put them in a bracket and we've added them. So that's a sum of them. So it's a half times that, and then times H, which is a perpendicular distance between them. So learn that off as well, please. And then we'll look at an example of how we actually put this into practice, finding the area of a trapezium. Okay, for this one we've got a vertical trapezium as I mentioned earlier. So write down your formula, half A plus B times H. In this case, A and B are your parallel, well, in all of the cases A and B are parallel sides, but the parallel sides are 8 and 6. Doesn't matter which way around you put them. And their perpendicular distance between them is 5. So just tidy this up. That's a half times 14 times 5. In this case it's easier to do a half times the 14 give you 7 times the 5. Which is 35, and that's going to be 35 centimeters squared. There's a wee mistake there, that should have been 5 centimeters, so we just change that to 5 centimeters on your notes. That would be great. Okay, the next one is the area of a kite. So the area of a kite is a half times the product of its diagonals. Okay, just say or area is equal to a half times D subscript 1, D subscript 2. That's just another way some people like to write it. So a half times D1 times D2, so diagonal 1 times diagonal 2. Okay, now you need to know a couple of things about a kite to be able to do this next example here. So the first thing you need to know is that this the shorter of your diagonals is bisected is bisected, so it's cut in half, so that's 8 centimeters. It also cuts it half at right angles. If that's 8 centimeters from here to here, then it's also going to be 8 centimeters from here to here, so label it this way. So we'll just say D1 in this case is 8 plus 8, so it is 16. D2 is 7 plus 11, so it is 7 plus 11, so it is going to be 18. So your area is equal to a half times, and we'll say D1 times D2. So in this case, that's going to be a half times 16 times 18. And I would just do that on my calculator. Half times, or you could just work it out. Half times 16 is 8, and then times 18. And that works out to be 144 centimeters squared. Okay, a rhombus is 4 equal sides and its diagonals bisect each other at 90 degrees. To find the area for a rhombus, we can use either the formula for a kite or a parallelogram, depending on the information available. So let's just look at that a wee second. You've got a rhombus. So here, a rhombus, clearly a rhombus is just a same as a parallelogram. So it's got base and it's got a perpendicular height. But also, you could look at it as, because its diagonals bisect each other at 90 degrees, then it is also a special kind of kite. Alright, so you can use whatever one works for you. So in this example it says find the area of the rhombus below. We haven't actually got our rhombus. We're just going to draw a rhombus like this. So it's a 5 centimeter rhombus, so every side is 5 centimeters. And also another wee bit of information we have is that the perpendicular height is 3 centimeters. So in this case, the area, you would use base times height. So it's going to be 5 times 3, which is going to be 15 centimeters squared. Okay, in the next one, can you draw out this rhombus? That is 3, and we'll call it 3, well not give it any units, actually 3 and 3, and then it is 8 and 8. So that tells you it's a rhombus because the diagonals have been bisected. And we're going to use our kite formula. So area is equal to a half times the product of the diagonals, so D1 times D2. Now a wee bit of working out here to get your D1. D1 would be 3 plus 3, so it's 6. D2 is 8 plus 8, so it's 16. So it's then going to be 6 times, I'm doing a half times the 16, it'll be easier. 6 times 8, which is going to be 48 units squared. Okay, we're going to look now at composite shapes. Now, composite shape is a shape which is just made up of other regular shapes which we know, so we can split up that way and then find the area of the whole thing. So we're going to look at 2 examples now on how we can do this. Okay, this first example we've got this sort of L shape, and we're going to split it this way. We're going to call this shape 1 and call this shape 2. So 1 is going to be equal to, so we may need to find some missing heights. 5 is a whole height from here to here. And if this bit's 2, that means this bit must be 3 centimeters. So 1 is just going to be, what else do we know? If we know this whole length is 4, and this bit is 3, that means this wee bit here must be 1 centimeter. So area 1 is just going to be 1 times 3, which is 3 centimeters squared. Area 2 is going to be equal to, and it's going to be its height, it's going to be 2 by 4, which is going to be 8 centimeters squared. So we'll just say the total is equal to 3 plus 8, which is just going to be 11 centimeters squared. Okay, our last one, we'll just add in on another couple of dimensions, or one more dimension even will do us. That's going to be 20 centimeters along here. So we've got our triangle 1 and we've got our rectangle 2. So the area 1, for 1, the area is going to be equal to a half times the base times the height. And in this case, that's going to be a half times 20 times 10. A half times 20 is 10 times 10 is going to be 100. And for 2, your area of 2 is just going to be base times height. It is just quite simply a rectangle. So 20 times 15, which is going to be 300, and then just say your total area is just going to be 100 plus 300, and 100 plus 300 is 400, and let's give it units this time, centimeters squared. Alright, so we've gone through the areas of some basic shapes. We've looked at parallelograms. We've seen in this one, we've seen triangles, we've seen rectangles, we've seen trapeziums, and we've seen kites, and we've also seen composite shapes. So you can basically, any shape that that is made up of any of those things, you can find its area now by splitting it into different parts, and you're now able to find the area of any composite shape.